Okay, 4.5, solving polynomial equations, page 190 through 193. Today we're going to talk about repeated solutions, and it's just a solution that appears more than once. And in concept number 1, we're going to solve this polynomial function. Here I have 2x cubed minus 12x squared plus 18x equals 0. Again, equals 0 means I'm solving for x. Factor out your greatest common factor, happens to be 2x. That gives me x squared minus 6x plus 9 equals 0. And this happens to be a trinomial square, perfect square, perfect square. If I take the factors, or the square root of x squared, it's x. The square root of 9, it's 3. Take that middle sign right there. If I multiply them together, I get negative 3x. If I double it, I get that middle term. I get 6x. Okay, next I would set each factor equal to 0. I'm just going to do it up here. 2x equals 0. X minus 3. Quantity of that squared equals 0. Solve by dividing by 2. X equals 0. Take the square root over here, both sides. And here I get x minus 3 equals positive negative 0. Now, normally we just don't even worry about that positive and negative, but I'm going to leave it there for now. Because when I add 3 to that, I get x equals 3 plus and minus 0. Well, what's 3 plus 0? 3. What's 3 minus 0? 3. So really, I have these solutions, right? And x equals 0 and 3. And normally we wouldn't write that second 3 there. But this time, for right now, I am going to write that second 3 there. Because it really means I'm going to hit that twice. Alright, when I graph it. Okay, so if you wrote for an answer like this, x equals 0 and 3, totally acceptable, actually, because those are the only solutions. But I am going to hit this 3 again when it's graphed. So that's why I'm putting it in there, and that's where I'm going to show you here. So, if you didn't write that second 3 and you were solving, you get it correct. Okay. Alright, here we go. Concept number 2, finding the zeros of a polynomial. Find the zeros. F of x equals negative 2x to the 4th power plus 16x squared minus 32. Sketch the graph of the function. Okay, so what we're going to do is we're going to solve. We're going to use our end behavior. We're going to plot the points and graph this. Alright, so here we go. Just scoot it up. Alright, I have negative 2x to the 4th power plus 16x squared minus 32 equals 0. Switch your f of x for 0 when you solve for x, right? Take out your greatest common factor, happens to be negative 2. I am left with x to the 4th power minus 8x squared plus 16 equals 0. And look to continue factor. Maybe I have. Take the perfect square. So just like the other one, I'm going to take out those. I'm going to take that middle sign. If I multiply them together, I get negative 4x squared. Double it, negative 8x squared. Put that power 2 right there. It works. Set each factor equal to 0. Negative 2 equals 0. Well, it does not. Right? So that one you can just cancel. Alright, this one though. X squared minus 4 squared equals 0. I'm going to take the square root. And now I get the quantity of x squared minus 4 equals positive negative 0. Alright, so I'm just going to bring this up and continue on here. So, I'm going to add 4 down here. Why not? X squared equals 4 plus 0, which is 4, right? And then 4 minus 0, which is also 4. So maybe I'll even just write it twice. And now I take the square root both sides. I got x equals positive negative 2 and x equals positive negative 2. Which really means, right, I got x equals 2 and 2 and negative 2 and negative 2. Okay, here's our repeated solution again, right? So if I put my points on 2 and -2, I can't really put it again, right? It's done. But I'm going to show you what that means when we graph. Okay, next, I'm going to plot my y-intercept, which is 0c or 0, -32. So let me just show that here. So I got 2, 0, right? -2, 0, and 0, -32. Let's plot that. I'm going to go by 4s. 4, 8, 12, 16, 20, 24, 28, 32. Okay. Now, what I need to do is my end behavior. Okay, so let's go ahead and do that. F of x approaches blank as x approaches -infinity, and f of x approaches blank as x approaches positive infinity. Alright, so if I look here, my degree is 4, which is even. My lead coefficient is -2, which I need to know the negative. So even negative. Well, even tells me it's going to go in the same direction, up or down and down. Negative tells me it's going to go down and down. So that's -infinity, -infinity, down and down. Okay, so when I graph this, I'm going to start going down, and I'm going to hit this, but I'm not actually going to go through this point. I'm just going to like hit it twice. It's like I'm hitting that -2 twice. So it's like I hit it, it goes back down, go back up, and then I hit it again, and goes back down. Alright, and I always liked to do this with sound, and it kind of goes like this, right? When you hit it once, you just go dish, right, and it goes through. But it's almost kind of like bouncing something against the wall, like you just dish, right, and comes back. But if I hit it like on the bottom of a wall, it almost hits twice, right? So it's like it goes up, it goes dish, and then goes back down, and dish, and then it comes back down. Alright, so that's how it kind of works. Okay. Number 3, go ahead and take a little time to do that on your own. Pause it and do that. I'm going to show your answer here in just a second. Okay, pause now if you haven't already. Alright, there is the answer for number 3. I didn't quite show as much work there. I just used plus and minus 3, but I knew it was hitting twice. So there we go. And I'm going to go ahead and flip it on up and show our next part here. Okay. The next part is our rational root theorem. Alright, and if we have a polynomial, then we're going to say P over Q. P is the factor of your constant terms at the end. For example, 20 is your constant term. Over Q, your factors of your lead coefficient. In this case, my lead coefficient is 1x cubed, so it'd be factors of 1. So it'd be factors of 20 over factors of 1. The rational root theorem only lists possible solutions. Alright, gives all the possible solutions there. And then, to find the actual solution, you're going to have to test these values. Alright, and we're going to use synthetic division because it's going to make things a little easier for us. And that's how we're going to go about it. Now, this is a pretty challenging concept because there's lots of possibilities, right? And what do you choose? Well, it's a tough one, right? I can't really tell you. Sometimes you just want to start from the low or whatever's easiest and go from there. But doesn't always mean you're going to hit your factor that quickly. Alright, so what I'm talking about is here. Concept 3. Using the rational root theorem, find all the real solutions of x cubed minus 8x squared plus 11x plus 20. Alright, equaling 0. So I'm going to take my p over my q. Alright, so what I have is my factors of 20 over my factors of 1. So factors of 20, plus or minus 1 over 1. Plus or minus 2 is a factor of 20 over 1. Plus or minus 4 is a factor of 20 over 1. Plus or minus 5 over 1. Plus or minus 10 over 1. And plus or minus 20 over 1. Okay, so there are all the possible solutions. Positive negative 1, positive negative 2, positive negative 4, positive negative 5, positive negative 10, or positive negative 20. Okay, so what I'm going to do is test these. Alright, and first thing I'm going to do is just test 1, right? So like, would the factor, and I'm just even going to write test here, to x minus 1. I'm going to test 1. So I put 1 out, I go ahead, and then I use synthetic division, which gives me 1, negative 8, 11, and 20. Bring down your 1, multiply it by 1. Combine, you get negative 7. Multiply that by 1, you get negative 7. Combine those, you get 4. Multiply that by 1, you get 4. And I get a remainder of 24. Does that work? No, I'm looking for a remainder of 0. That does not work. It is not a factor. What I would do would be move on to the next one. Okay, so here we go. I'm going to test the factor of x plus 1, which is negative 1, right? 1, negative 8, 11, and 20. Bring down your 1, multiply it by negative 1, I get negative 1. Combine those, you get negative 9. Multiply by negative 1, I get 9. Combine those, you get 20. Multiply that by negative 1, I get negative 20. Combine those, and you get a remainder of 0. Does this work? Alright, yay, it's a factor. It only took 2 tries. Alright, it may take you much more. Alright. Alright, now, what do I know? Well, I know that this x plus 1 is a factor. What else do I know? Well, I know that x squared minus 9x plus 20 is a factor. Alright, but can we factor trinomials? We sure can, and we're going to try to see if I can factor even farther. So I'm going to bring down the x plus 1, and I'm going to look to factor this to 2 binomials. I know x times x is x squared. Can I think of 2 numbers? First of all, negative in the middle, positive on the outside means it's a negative, negative. Negative times negative is positive. That adds up to a negative. Can you think of 2 numbers that multiply to give you positive 20? They add up to give you negative 9, negative 5, negative 4, and voila. There are all my factors. Perfect. And now, can I find the real solutions? Absolutely. I just set each factor equal to 0. X plus 1 equals 0. X minus 5 equals 0. X minus 4 equals 0. Subtract 1. Add 5. Add 4. X equals negative 1, 5, and 4. And done. Now, I didn't probably have to go this route and put that there since I already knew this was 1. I could have just put that there and just worried about this second one. But I just wanted to show you everything all together there. Okay. Pause now. I'm going to go ahead and show the answer for number 5. Give number 5 a try. Okay. Here we go. I'm going to show this right now. There is the answer for number 5.